I was told to talk in English. I would have loved to do it in Spanish, but unfortunately my Spanish is fairly good. It's certainly not good enough to stand in front of all you good guys and talk about Groovy. So, I'm going to be doing a talk quite pretentiously titled Architectural Flexibility Using Groovy. Now, I am a pretentious individual. I think a lot of myself, so that's why I choose pretentious titles. So this is me. My name is Dawson. I run a software consultancy in the UK called Simplicity itself. We do lots of things, Grails and Groovy being one of them. So I want to start with a question. This is a real question. I want you to answer it. What kind of code do you think is best? Object-oriented or functional? Object-oriented. Put your hands up. Not many. Not many. No. When I did this talk before, it was much more of a split towards OO. Functional. Apparently, some of you don't like to program.
Or a combination.
Strongly typed or weakly typed? Strongly typed. Yeah? Weakly typed? Both. Hey, here we go. We're rocking. What about meta class? Do you use the meta class or not? Meta? Not meta. Do you guys know you're using Groovy? What about data type? This is something you may not have thought about. So by type, I mean class. So who likes using classes? Data structures. So in Groovy, you might make these using lists and maps or something else, but not a class. Both? Yeah. So we're thinking maybe we like all of these things. The question I want to put to you is why? Why do you like these things? Why do you like one? Why do you like the other? Why do you like both? Why do you like these things? So there'll be a lot of things that are kind of pushing down on your code, making you choose these things. So one of the obvious ones is the non-functional requirements. These are my favourite kind of things to be thinking about when I program. So transactions a second, latency, deployment concerns, things like this. These change the way you program, whether you realise it or not. Developer comprehension. So this is, you look at a piece of code, understand it. You can read it. A new developer can come in and they can read it and understand what this code is and what it's doing. This is comprehension. This is another thing that's pushing on your code. Who has a coding style? So how many, hands up if you're a commercial developer, so you work in a company cutting code. So probably pretty much everybody. Who has a fixed coding style? Fair few. What you'll probably find is, whether you have an enforced coding style or not, there will be a coding style of some kind. And it'll be, if you don't have an enforced one with check style, or whatever tool you're using, there'll be some kind of senior developer will come along, take you aside and say, this isn't the way we do this here. I'm sorry, you need to go and change it. That's a coding style. He's enforcing a coding style on you. And it's very common. Again, this is another thing that's altering the way that you write your code. Data models. So who has a, think of a title, data architect or some kind of architecture team that's defining a data model, some kind of centralized schema for your application? Anybody? These were very popular a few years ago. No? One? We've got one. Whether you have a big kind of centralized data model or not, the way that your data has to exist in your application, again, changes the way that your code is written. So your data requirements change the way your code is laid out in your system. And then any other things that are changing the way you write your code. So who would out and out admit, put your hand up here and now, that you just like functional programming? You just prefer it? No real reason, you just like it. Not many. We've got Russell. But I think you should admit to yourself, a lot of your You'll be saying, oh, I write code this way, I write code that way. That's, a lot of the time, it's just down to bias. You simply like it because you like it, it makes you feel good. There isn't any other reason. And that's okay, but you have to be aware of it. You have to admit that to yourself. So I call these forces on code. These are things that are changing the way you write your application. And I want to go through some of these now. I want to go through some of these now. Pick different bits of an application, see what the forces are, and how they change the code is written, how they change the way the code is written. So I'll ask you again, what kind of code is best? As you may have gathered, this is very much the wrong question. So I started with a trick. I'm very sorry. I'm not really. I'm going to be doing it through the talk. I will be asking you trick questions. So, something's missing from this. Come on. Yeah, something's missing. And that's our application. We need an application of some kind. It's a very contrived one. I've made it up. But in drawing an application, you have to kind of think about where your code is, what it's doing. So I'm going to draw a little application for you, and then we'll pick different bits of it. Start off with the central bit, the core domain. This is business policy. This is all the kind of the rules of your application. So you may have heard it called business logic. What's the term in Spanish for business logic? Anybody?
Lógica de negocio.
We call it logic. So wherever this logic is, if it's smeared all the way through your application or it's in one place, depending on how disciplined or how your code is structured, it will exist. This logic does exist. And so we're going to be looking at that. There's also all the other bits of your code. So your core domain will be communicating with the outside world somehow, maybe through a REST layer, maybe through some events. So I was picked up last time for pushing events too hard. I do like events. They are not the only way to structure an application. Maybe you're providing some API that someone else is using. If you're in a big team, you're developing an application, well, a JSON, but someone else is using that. That's an API. Or you have some kind of DSL that you're using, or developing, providing to users. This then gives us context. So our application that we've just seen, you can start to imagine in your own mind, looking at those different areas. Ask, what's the best piece of code? What's the best kind of code for this area? This gives you context, and that's what you need. You always need context when you decide what code is good and what is bad. So, picking one of these areas, I'd like to say at random, but obviously it isn't, the core domain. So we throw that up there. Now we'll go through our forces. So there's things that are pushing down on this code, on this application, this area of your application. So in your domain, you will have types. You will be expressing these types. You will have identity entities. So you'll think about your application, say in Rails, you have your domain classes, persistence classes. They're expressing an entity. Coming from your database, yes, but it doesn't matter. That's almost irrelevant. There is some kind of entity there. Identity. So they will be expressing what we call the ubiquitous language of the application. So have any of you come across domain-driven design, DDD? One or two? Yeah. Okay, so one of the so ubiquitous language as a concept predates DDD, but it features very heavily in it. And the idea there is you define a glossary. So you come up with a term, and you define what that term is. And you define it in your code, you define it in your developer's mind, you define it in the business as well. So it's a shared term. So you have one word that's used throughout everything, from the business all the way down into your code. And this is where the ubiquitous language will show up in your core domain. This is where you're making your policy decisions. And so you should be using the terminology of the business when you're making decisions that are going to affect the way the application works. I found that you tend to have relatively high code churn, so the code will be changed fairly regularly, quite often, reacting to business changes. So I do a lot of development for banks in London, And the regulatory changes coming through are just unending. New regulations come through every week. And the code has to be changed to match that. So the code will be changing fairly regularly. So, you need entities. This is UML. Who remembers UML? Yeah. It turns out it was actually a good idea, but people misused it, as they always do. So in your core domain, use UML. It's a good idea. So UML was designed to kind of understand entities. You know, it's one of the core words in UML, the entity. So use UML, map your structure of your application out. Don't spread UML into the rest of your application. Don't bother, it won't work. And that's what people failed with. So we have our UML diagram. It's good. We need identity, so you have an identifier. And now we can actually look at the code that falls out of that. So who thinks this is good code? Trick question, remember? It's obviously not. So there's quite a few problems. Possibly not obvious to some of you. If you come into Groovy, you may write code just like this. And without realizing that I think it's a bad idea. And I value my opinion very highly, so. So primarily, this is a problem. So we had weak typing here, duck typing. However, if you look in this method cannot handle anything. You could pass a string into here, no one would know, no one would care, until you got to this bit, when all the expectations that are built into this method, that only an order comes in, start to throw their hands up. So if you have a method that can only take an order, say so. And if you have a method that will only ever return an order result, say that too. And so what we end up with is this, a full method signature that's strongly typed. Okay, next thing. The method name. Process doesn't really mean anything. I don't know if there's a similar kind of catch-all word in Spanish, but in English there's too many things called process, or do, or, you know, it's very easy in Groovy to kind of, like we're doing here with the defs, to get a bit lazy. So Java is it's much higher on ceremony, because it's got all the extra compile steps, and you have to do extra things, so the ceremony is there. Groovy strips a huge amount of that away, which is generally a good thing, but it can also act to make you a little bit lazy when this kind of thing comes up. So you need to make sure you don't give in to that. So, any questions on that one? You all happy? If you do have any questions, throw your hand up. It's okay, we're in a fairly small room, so it's not a problem. So, pick another one. I'd like to say at random, but obviously not. Events, so they're up there. So we're going to look at an event processor. So all of you, who's done event architectures or used events? Fair amount. So I do very much like events, however, I would keep on saying it's not the only way to structure an application, or I'll get told off again. But it's essentially what you've got here is a dispatcher. So you have events coming in, some kind of subscription in the dispatcher, and it then figures out where to send the event. Fairly simple, fairly straightforward. You could write this, all of you, I'm sure. Subscriptions then fire and the events fly out. So what are the forces on this bit of code? Sorry, guys.
Thank you.
What are the forces on this bit of code? Primarily performance. This thing has to be fast, that's it. It just has to get the job done as rapidly as possible. Because if you do introduce this kind of structure into your application, everything will flow through here. All of your code will at some point touch the event processor, the dispatcher. So it has to be extremely fast. It's also very technically focused. So what you'll find is that the entities that we're looking at in the core domain, they don't really feature here. They don't exist. All this is interested in is events and subscriptions, not in orders or users or any of that. That doesn't actually matter. They may be embedded in the events, but your dispatcher doesn't know, doesn't care. So use technical language. Your ubiquitous language doesn't exist here. No interest in type identity, functionality, yeah. So these are interesting ones. So in discussions on classes, on types, people talk about different things. So a class, as you see in Groovy or Java, is actually encapsulating several different things. So you have the idea of identity, you have the idea of what functionality it can provide to you, and then you've also got what the data schema is. So it can act as a schema, an explicit schema for some data structure. You need to unpick those and figure out which one you want, which one you're interested in, because it might not be all three. So in this case, an event processor is only interested in functionality. It's not interested in identity. And then it's interested also in the data structure that's embedded in there. But identity is not part of it. So here we have a very simple dispatcher. Is this good code? You lot are on to me. I'm going to have to come up with better tricks. So the answer is maybe. You know, it's fairly readable. So what we have here is a little closure doing a find. So it finds all of the subscriptions that can handle this event. And then, second level, it dispatches them. So we've got a nice little functional chain, which is good. So I ran a little test on my laptop. I can't actually remember if these were the real numbers or if I've just made them up. It's possible I just made them up. But it's there to illustrate a point, so I hope you'll forgive me. So 200,000 messages through this took 450 milliseconds, which, if you're interested in shoving as much data through as possible, is really slow. It's dog slow. You know, it should be way faster than this. So this would never make a cut as a dispatcher. It's just too slow. However readable it is, it's too slow. However, Groovy is a very flexible language. We don't have to do it this way. We can do it other ways. If we replace the little functional chain with a for loop and an if, things change. What we were doing before was a two-phase process. It doesn't have to be a two-phase process. You can do it all in one step. That also removes the creation of an extra list, which, if you're looking here, find all will generate a new data structure at this point, and then this operates on the new structure. So you've got an intermediate step that we can just get rid of. And that's what we do. We use a for loop. There's no intermediate list. There's no kind of executing of closures, which, due to kind of Groovy dynamic dispatches, can be a little bit slow when you're doing this much of it. And that goes down to 80 milliseconds, maybe, assuming you hadn't made up the numbers. We can do better. So this is Groovy in its default dynamic mode. If you use compile static, then this switches Groovy. It changes the personality of Groovy completely. It's no longer a dynamic language, it's a static compiled language. So use this with care, because it does change the way things work. But in this case, it changes them for the better. Because what that does then is remove all of the dynamic dispatch and makes things significantly faster. It's more than twice as fast by simply adding a little annotation, which is quite good. So this then becomes suitable. You can throw these messages through and it's more than an order of magnitude faster, which is good. Everyone happy with that? Question?
How will it compare to Java?
How will it compare to Java? Java will be slightly faster. That's what all my tests say. So, REST. I'm not really interested in the REST with the outside world bit here. What I'm interested in is this, crossing a domain boundary. So, when I structure my applications, I structure them for maintenance primarily, not for kind of the initial development speed. Because what I tend to do is work with applications for quite a long time. And so knowing that, 2 years later, I want to come back and be able to actually carry on development. And so what I will do, we have our core domain with all of the entities. In the REST domain, I will have another set, a different model, a REST model, some kind of data structure that's optimized for REST. And then in between the two, there'll be some kind of conversion. And that's what I'm interested in, this transformation process. Throw that up there. So, the reason your applications, who's using REST? Grails, REST, fair few people. Do you do any kind of JSON transformation from so you have a domain class and you want to render it as JSON? Yeah? You're actually doing this already. You are taking your core domain model, your Grails domain classes, and you're translating them into JSON. Now you may be happy with just using the default Grails render as JSON. That's doing this. That's taking your domain class and rendering it as JSON. And that's what I'm interested in, is kind of the conversion process. Many places I've been to are not happy with that because that exposes things like database identifiers in the JSON, which often you don't want. So there will be some kind of conversion process going on. So, in this crossing of the boundary, what will be going on here is integration. You're integrating your REST code with your core domain. And if you'll follow my advice, it will be explicitly destroying and removing all of the type information as well. Because that type information coming from your core domain is very much tied up with the identity of the entities. And that's not necessary in your REST code. You want a different model in your REST that's optimized for REST. And so your core domain will contain your core model. Your REST domain will contain your REST model. They will be separate. So you want a translation process between the two. That implies that anything coming out of your core domain will have to be turned into data. And then a new model will be created from that data. So this transformer will be destroying types as it goes through the code. Because it's doing that, it's only interested in data. It's not interested in types. It couldn't care less what the core type was. It's only interested in the data inside it. So we're talking about before with classes having different uses. So schema, data schema, functionality, and identity and type. This is very much interested in the schema. So it's treating your it's treating your core domain model as a schema, a data schema, an enforced data schema that you can compile check, which is great. That's lovely. But it's a data schema. And then it takes that data and translates it into something that's suitable for showing to the world as JSON. So, if you take a simple kind of a transformer, so who's written like this kind of transformation before? You take one class coming in, another class coming out. Yeah? I'm sure you all have in some way. So this is the simplest possible one you could do. And this is the transformation. It's not a very clever one. Somebody made a typo and forgot to put an E, and so we need to transform it to fix their typo. Yes, I made a typo. But this is essentially what's going on, and you'll find this code everywhere. And curiously, this is in fact all that's necessary. This is all we want. The rest of it is just noise. This is only there because it has to be. So including class, all of this, all of the method, creating a new REST message, all of this is just noise. We only do that because that's what we think we should do. But we could get rid of it. For the sake of argument, follow me along with this. Let's junk all that. We've got 2 lines of code. What can we do with them? Well, first off, we don't need the REST message anymore, REST message class. We're only interested in data. So this is taking data from the core domain and giving data to the REST domain for it to do what it wants. So we don't need classes, only data. Our map in Groovy is great. And then Groovy gives us a very nice structure for this, which is the closure. So we can actually take this code and wrap it in a little squiggles. And we have what we had before. It turns out our class was just a function in drag. So we can just move it to be a function. And then once we have that function, it's a bit sad. Track back. It's a bit sad. We take this transformer function, we can execute it and say, take this message and send it to here, and it does its transformation. Wouldn't it be good if we didn't have to tell it where to go? We don't want it to know where it's actually sending a message. We just want to say, do. And you can do that in Groovy. So if you ever done any kind of functional Groovy before, so have any of you done kind of proper functional programming in Groovy or any other language? A few. Good. So what you'll find is what is a concept called a higher order function. This is a function that creates functions. And Groovy's got plenty of them. They're brilliant. So here I'm using one, which is curry. So this will take my function, my closure here, which has 2 parameters. It then allows you to capture an argument like this, curry and then some random target. It allows you to capture that argument and create a new closure, a new function. So here I'm replacing transformer with a new function that I can execute that only takes 1 parameter, which is the message. I could do with that being there really, couldn't I? So this transformer function will now only take a message, and the target that it's sending it to is pre-populated via the curry higher order function. Any questions on that one? Yes?
Sorry, suppose it seems that closure currying is slow. Is it or not?
Is currying slow?
Yeah.
The actual curry call isn't. I don't believe that.
I mean, using transforming closure after curry.
So if I was to then is this method called slow? Sorry, is this called
Yeah.
slow? I don't believe so. Anyone in the room care to comment?
Compare it to script code to with target.
My belief, and this is a belief, is that there will be no difference in how fast they are to execute.
Okay, thank you.
It's worth testing, but I can't see why there would be. Good question. So, we've done transformation, where we've seen types being stripped away, and we reduced down to data and functional programming in Groovy, crossing this domain barrier. Next one, a user DSL. So, throw that up there. Forces. Who has used a DSL? Who has used Grails? Really? So you're all Groovyists on the Groovy side. Interesting. If you've ever used Grails, you would use plenty of DSLs. Groovy has a nice affinity with DSLs. It's quite easy to construct them. However, I would strongly recommend that you don't. They are hard. They're easy to do technically. They are hard to do from a user point of view to actually make something that flows and have to express what you want. So forces on a DSL, user comprehension. A user has to be able to read these and write them, in your new language. They have to be able to do it. And so comprehension is king here. They have to be able to express themselves. So the thing that they want your application to do, they have to be able to write that easily. So this one, I don't know how well it'll translate. Ease of use versus intuitive. In English, people get confused by these terms. They think they're the same, but they aren't. So intuitive is where a novice, someone who has never seen your system before, can look at the code or look at whatever they're using and understand it straight away. That's intuitive. Ease of use is very different. Ease of use is where someone who knows how to use your application already can get their job done quickly with no kind of impediments or things in their way. That's something that's easy to use. Sometimes something can be intuitive and easy to use. More often, it's not. It's one or the other. And that's what we're going to look at now. So in Grails, there is this, which is a dynamic finder. So what this does is we have an order domain class. And then Grails gives you the ability to simply type what you want out of the database. So here we're saying find all orders by using them, you pass in a parameter. That's fairly easy to read, would you say? You look at that, you know what it does. This is intuitive. However, you take things a little bit further, and it's really not easy to use. You can stretch this as long as you like. And I think probably at about this point, it becomes completely unreadable. I wrote that and I got confused when I was writing it, not even reading it later. So this is intuitive. Beware intuitive things. This, however, is easy to use. So this, in Grails, is the where query. This allows you to create a structured query against the database. Very similar to this. In fact, it's the same query, pretty much. Someone would look at this as a novice user. They might grasp it. They probably would. I think it's less intuitive than this, but it's far, far easier to use.
And wrong. Because now less than.
Ah, yes. Yes. It's almost the same query. So this in Grails is compile time checked, which is lovely. It's great. It's if you make a mistake, well, if you make a syntactic mistake, the compiler will find it. If you miss out this mistake, then obviously it won't. Logic errors. Sorry. However, I'm a bit ambivalent about this. I'm not completely convinced. And I'll use this to kind of highlight just how hard DSLs are to make. Which is this bit here. So this is a very hard problem to tackle. Querying databases in a structured way is hard. Absolutely. This, however, troubles me greatly. So in Groovy, this says regular expression. In a database context, this is no regular expression. This is part of a where-like query. And the semantics of it are quite different. So this, in my book, is slightly confusing because you think you're doing a regular expression. You have to switch in your mind and say, no, I'm talking to a database, I'm doing the like. So this is there to highlight why DSLs are hard, because these kind of things crop up. If a user's expressing themselves, this could confuse them. So, just to flip back to the code, how do we do that? Yeah, we did fine. Flip back to the code. So I was asked last time we did this talk. So would I remove all eaches and use for loops because they're faster? That was kind of a question, and it was a good question because if you were to look at all the slides up to now, I've gone and done that. I've removed eaches. So I wanted to give an example, again from the core domain, showing that the force is operating the other way. And this is why. Relatively high code share in your core domain. This is what I found in the business policies changed quite a lot. And so because you have relatively high change in your code, you have to be able to handle that. The code has to be amenable to being changed a lot. Otherwise it's going to slow you down. And so that will then affect how your code is written. So here we have a very simple, very Java style service in your core domain where we find all the records that a user is allowed to see. To do that, we look up all the orders, then we generate a new list of all the orders that a user is allowed to see using a for loop and an if, just like we had before. This was the end result of the example I showed you before. This would be fast. It's also a bit unreadable. It's not the easiest thing to read. Having used Groovy for a long time, this feels kind of ugly. So what could we do? If I was to change this quite a lot, I could see mistakes creeping into this code because it's not completely clear when you first look at it what its intention is. So we need to fix that. We need to show the intent of what this is doing much more clearly. Don't know why I did that. Yeah, there we go. Right, so actually, no, I do remember now. This is a method on a class on the core domain. So you will be expressing type. So I was showing you before, actually introduce type into a kind of very explicit signatures in your application code. Make it clear what your code expects to come in and what it will return. That has to be very clear. However, we've expressed type all through the code. And this, in my book, is noise. It doesn't need to be there. You know, this is necessary, this is not. That's there because you think it should be. But thinking about it, it doesn't have to be. If we were to remove it, suddenly this code has less going on. I can read this more clearly. Now we look at the for. What can we do to this? Well, so what this is doing, we're iterating the orders, and then we're doing a selection to find all of the orders that a user is allowed to see. Groovy lets you do this much more easily, like this. So we've actually managed to remove a huge amount of code by just using a little feature of Groovy to do a find all on a list. Far more easy to read, a lot less going on.
Why wouldn't you just do that in a database?
Sorry?
Why wouldn't you do that in a query in a database? Why pull all that data back and then filter client side?
So the excellent question is, why wouldn't you do this in a database? The answer is because I wanted to show it in code. But thank you very much for the question. Yes, if you could do this in a database, you would. That's the best place to do it. If you wanted to, for example, do a check with some authorization system, and say, so for example, if we had our order, and in the database it didn't have a user record, but we could attach it afterwards, and then do our check, maybe you would do something like this. But it is an excellent question. So we could actually reduce this completely and just do it all on a database. However, we're also doing this little natty sort down here, which is really unnecessary when we just do this. So here we're moving back towards the functional pipeline that we saw before. The functional kind of pipe that I told you to remove because it wasn't performant. Here, it's necessary because this isn't actually as interested in performance. This is interested in comprehension. And this is much more readable. And then, because this has got relatively high code churn, we were told to add something. So we have to change the type that's coming out of this method. So instead of being an order, it's an order details. So we have to do a mapping process. So I've added an extra step into the functional pipeline to then translate the code. And so we're generating an order details class. So, to kind of wrap up slightly, your takeaways from this. When you're writing your code, understand your context. You have to know where the code is, what it's doing, what's affecting it. You can't just come in and say, this measure of code is best because I think it is. Because that's bias. And that's okay. Doing something because you like it is okay. But you shouldn't do that to exclude everything else. Understand what's going on. And then write your code. So this is the process I would say go through when you're writing. And lastly, dogma. So reject any dogma. You don't need a religion when you're writing code. Saying that functional is best because functional is rah-rah is no good. You're all professional software developers, you should know better than that. So any kind of final questions? We've got a little bit of time. Everyone happy?
Can you get back 2 slides?
Yes?
Yeah.
Question? No? Come on, someone ask any question. Yep. Destroy the types, yeah.
How would you still have data types? Talk about transformer, but in the transformer actually destroying.
Yeah.
So you're transforming data types, destroying.
So the rest, what I find is it's an excellent question. Kind of why did I talk about destroying types, going from your core domain to your REST domain? What I found is specifically with REST is what you actually need is some kind of representation of your data that's very easy to translate into JSON. Now the easiest one that I found in Groovy is a map. It's the easiest mapping between JSON to some kind of Groovy data structure. So that's why I would say in that instance certainly remove all types, just go to maps and lists, because that's the easiest translation. To kind of answer the question more fully, when you're crossing the boundary, having your core domain model exposed to all the integrations around it starts to pull that model in different directions. So your REST code has to do one job. Your eventing code has to do one job. If you take your core classes and push them into those areas, your core classes have to do all their jobs as well. So that's why I'm kind of arguing, say, keep your core classes in a very confined area. So I'll actually be going through a full example of that kind of idea tomorrow in my other talk. So if you're interested, come to that, or Russell's doing an excellent talk as well at the same time, unfortunately. You'll have to pick. Right, well, if there are no other questions, thank you very, very much. Hope you enjoyed it.